Hello YouTube, this is UMozo3. So for many videos now, we've been talking about algorithms, and we looked at three different examples of sorting algorithms and two different examples of searching algorithms. And we basically said that algorithms can be characterized on account of how efficient they are. Basically, how many steps does it take Python, or how does it take the computer to execute a particular task, right? And there are different ways to sort a list, and we saw that some of them are more efficient than others, right? We saw that insertion sort was more efficient than bubble sort, for example. But we looked at different examples of these sorting algorithms. And then also in the previous video, we looked at something called binary search. And we said that if you were searching for an element in a list or tuple, if you had a sorted list, it would be a lot better to go ahead and divide it by 2 every time to basically look at left and right endpoints. And basically every time, if you have a sorted list, it would be much easier and much faster to look for a target element than if the list was unsorted. Because if the list was unsorted, the only approach we really have at our fingertips is the linear search, and that's where you start at the beginning of the list and just work your way through one index position at a time. But with binary search, there's a quicker way of doing things, and we said it only requires a sorted list or a sorted tuple. And we talked about how any class can be sortable, right? We had sortable person objects and sortable point objects, and the only thing you need to do is make a less than magic method, a less than dunder within your class. So hopefully that's clear to you. But what we would do is we would basically just go ahead and pass in a tuple and a target, and we said that these are default arguments, that's left and right, so you don't really have to worry about those. But it's going to say, well, left is less than or equal to right, so every time the left is less than or equal to right, unless we break out, unless sorted tuple of mid gets equal to target, we're going to be running this logic over and over again, where we're going to repeat this computation of a midpoint, and the midpoint is going to be the integer division of left plus right over 2, right? It's going to be like the midpoint, and we're going to keep adjusting the left and right endpoints, and therefore our midpoint is going to keep changing, and the goal is for the midpoint to get closer and closer to the target element. You know, at that point we would go ahead and assign result to whatever the index position is at that iteration through the loop, and then at that point we'll have known that we were successful, and then we can just go ahead and return that index position. So then in the previous video, one of the things that we were looking at, if we go ahead and run this code, is we can see that we were able to sort these person objects according to the length of their names. And we did that with my guys equals insertion sort of my guys. And then we say for r and my guys, print of r. And so it was able to print out the 7 person objects on account of how long their names are. And then we said index position of y of name. So we used the get item dunder. And then we would just say the string representation of binary search of my guys comma y. Okay, and so since y of name, you know, that corresponds to Chris. So we were basically looking for the instance of the person class whose name instance variable was equal to Chris, right? And once we found that, we returned the index position. And so once that list got sorted, Chris was at index position 3, right, after Bo, Tom, and Kate. So hopefully that's clear to you, and that's what we talked about in the previous video. And then again, we just have to remember that Lambda functions don't have to accept any inputs, right? So again, we have my function 4 and my function 5. A few videos ago, we were talking about how if you just write Lambda and then a colon, that's an example of a Lambda function that doesn't accept any inputs, right? And then you can also have Lambda functions that just print things, right? So we could also have, you know, just print something, you know, equals Lambda t, and then you could say print of t plus 2. Okay, so this would not return anything, right? And so again, if you just say print just, what if you just say print of just print something, right? The printing is already being done. So what this would do is it would output the value of this function, which as we talked about previously is just going to be none, right? It doesn't really give an output to something. The function itself does the printing. So you don't have to print the output of the function because the function itself is already doing the printing, right? And I guess we would have to pass in the value of t here. So then if we go ahead and run this code, it would say 12 and none, right? Because the function doesn't return anything, but it does the printing. So you don't say just print something of 10. You just say just print something of 10. Okay, so hopefully that's clear to you. In this lesson, what we're going to do is we're going to talk about something called stacks. Okay, so stacks are another type of data structure. And basically what I think would be helpful is to think about a stack of dinner plates, right? So you can literally think of like a stack in the real world. So what we're going to do, essentially what I'm going to do here Let's just go over to Blackle and go ahead and get a sense of what a stack is, right? And this is a computer science concept. So you would see stacks in other programming languages too. In fact, I have a YouTube video about stacks in the Java programming language. So you might remember that I've also done all these programming tutorial videos for Java programming if you were so inclined to learn the Java programming language. But what we're going to do is we're going to consider a data type called a stack. And it's a data structure that serves as a collection of elements. And I think that this picture of dinner plates on Wikipedia is actually pretty helpful. But basically, there are two main principal operations. So there's a push operation. And basically what that does is it adds an element to the collection. And then there's a pop operation, which removes the most recently added element that was not yet removed, right? So if you think about a stack of dinner plates, right, if someone's putting a plate onto the top of the stack, if you were going to remove one of the plates from the stack, you would be removing the plate that was most recently added to the stack, right? Unless it was already removed. But basically, this is called a last in, first out. So LIFO, or maybe people will say LIFO, but it's basically a last in, first out data structure, because basically the last items to come into the stack are going to be the first ones that are removed, right? It's not like a line at a supermarket where the first person who comes in is the first person who serves, right? That's the opposite of stack. That's called a queue. And that's what we're going to be talking about in the next video. But it says considered as a linear data structure, the push and pop operations occur only at one end of the structure, referred to as the top of the stack. And literally that's the top of the stack, as you would see in this video. What we can think about now is how to implement a stack in Python. Essentially, what we're going to do is we're going to create a type of object that represents a stack. And so what we could do is we could write that here. So essentially, the goal is to create a class that represents or implements a stack, okay? We need to think of a last in. So we think of a last in, first out data structure, okay? And when we're looking on the Wikipedia article, it says that we have to support two operations. So we have to have a push operation, which will add an element onto the top of the stack, okay? And so essentially you can think about like a stack of plates, right? And so we could push a plate onto the top of the stack, or we could pop. So this would remove the uppermost element from the top of the stack, right? From the top of the stack. And so this would have been the most recently added element would then be removed. That's how a stack works. It's not like people at a supermarket, right? If you come to the supermarket first, you get served first. Here, if you come to the supermarket last, you get served first, right? It's like a stack of, it's like human beings were toppling on top of each other, right? And it's like the first person that gets served would have been the first person to join the mob first. But anyway, essentially that's how a stack works. So what we're going to do is we're going to have a class definition here. So it's just going to be called stack. And what we're going to do is this is going to be our constructor. So we're going to define init. So it's underscore underscore init underscore underscore. That's how we make a constructor. And so basically we would say this is a constructor. And so we're already very familiar with this type of function. It's responsible for creating an instance of a class, okay? Usually by assigning instance variables. And so what we're going to do is we're going to think about an instance variable called items, and the items is going to be a list. So this list is an instance variable that pertains to a particular instance of the stack class. So it's like a stack, a particular stack instance is going to be represented by this items list. So hopefully that's clear to you. But what we want to do is first we want to have a function that will be called isEmpty, and basically the role of the isEmpty function is basically this function, which will return true if and only if there are no elements in the stack. Okay, and so basically there are no parameters, right? There are no inputs to this isEmpty function, but we have just the word self in parentheses because that indicates to Python that this is an instance method. And so we would just say returns, and then we would basically say true if the length of the list representing the stack is 0, and then false otherwise. Okay, so you just have to think about the stack being represented by a list of elements. Okay, and presumably you're only going to be able to add or remove elements from either the beginning or the end of the list, but not from both. Like you wouldn't be adding elements onto the beginning of the list and then removing them from the end, but it would happen in the same direction, right? We were talking on the Wikipedia article, you would add and remove plates from the same direction, right? You wouldn't add plates on top of the stack and try to remove them from underneath. So hopefully that's clear to you. But this isEmpty method will just return true if the length of self.items, if the length of the list that was created when we instantiated our object is 0. Okay, so hopefully that's clear to you. And then one of the essential functions that we need with stacks is push, right? So what we're going to do is we would say basically, well, if we were to make doc strings and we were to, have good programming etiquette, we would say that this function is responsible for adding an element to the top of the stack. Okay, so basically what we would do is this essentially accepts a parameter, right? This would be sort of a modifier method, right? Because we're basically modifying the aspects of one of the instance variables rather than returning something for the user to look at. So hopefully that's clear to you. But what you would do is you would say item. So this would be the item to add to the top of the stack, right? So hopefully that's clear to you. And then what we would do is we would also think about, are there any return values? No, there are not. So you don't see an orange return keyword. It just says self.items.insert of 0 item, right? And then remember, recall that when we talked about lists, okay, we got familiar with the insert function, okay? And so basically, if you might remember from, I think it was probably lesson 9 or 10, something like that, or maybe lesson 8, but what we were doing is we basically said for a list.insert of A, B, inserts element B at index position A and shifts all subsequent elements 1 index position to the right. Okay, so hopefully that's clear to you. So it would just basically, it would just insert an element at the beginning of the stack, and it would shift all elements currently in the list, currently in the stack, just 1 index position to the right. Okay, so hopefully that's clear to you. So essentially here, like the leftmost side of the list, like the beginning of the list, would represent the top of the stack, right? And as you iterate through the list, you're basically moving down the stack, as you're moving closer and closer to the elements that were added earlier on, and as a result, they will be removed later. So hopefully that makes sense to you. But that would be push of self item, right? And so it just accepts one input, but you would say self.items.insert of 0 item. And so it would insert that element at the beginning of the list that's representing our stack. So hopefully that's clear to you. And then we're also going to have pop, and so pop is kind of the opposite. So basically this function will return and remove the top of the stack. So the first element in the list that represents the stack. And so what we're going to do is there's a few lines of code here. So what we're going to want to do is we actually return something and remove something, right? So we've often drawn distinctions in the past between functions that accomplish a task, like functions that print something or change the value of a variable, and functions that actually return something, right? Functions that output something. But here in this case, the function does both, right? So there's no inputs, right? If you're trying to remove an element from the stack, you don't have to parameterize anything. You don't have to feed anything in. It would just go ahead and remove the top element from the stack, but that doesn't require an input. But what it would return is it would return basically the uppermost element from the stack, which is being removed by this function. Okay, so that's basically what would happen. So this line of code identifies the element to remove from the stack, right? So it would be like that top plate. It would be the element at the beginning of the list, right? And so this would basically, this is a list function. So it's an operation on lists that removes the element to remove. So it removes the uppermost element, right? And then basically, finally, return the element that we are removing from the list, from the stack. Okay, so hopefully that makes sense to you. But it identifies the element, it removes it, and it returns it. That's what the pop method does. Not only does it return it, but it removes the element as well. It pops it off the list and gives it to you. It say, hey, here's what I deleted, right? Peek is different. So peek is a little bit different. It's still going to return the top of the stack, but it's not going to remove it. So this returns the top of the stack without removing the element. So basically it just returns the uppermost element, but keeps it in the stack, right? So it would basically be like if you had a stack of dinner plates and you just wanted to know the color of the one that was on top, right? But it's like, you know, if you were popping it off, you would be looking at the color of it and removing it from the stack. But here with peeking at it, you're just looking at the color of it, right? So this basically, this just returns the uppermost element from the stack, which we're representing as the beginning of the list, without removing it. So there's no operation to remove it from the list. The list is unchanged. We're simply looking at the beginning of it. So hopefully that's clear to you. And then finally, we just have one more function here. So basically what this is, and this is going to be a void instance method. So it doesn't return anything, but it prints, it prints a representation of the stack. And so basically simply prints each of the elements in the list that represents the stack. And so I want to basically show you how the elements would be printed and how a stack would be printed. What does it mean for the elements to be iterated over as we add them and remove them from the list? So we can go ahead and try out some of the stack functionality just to make sure that you're familiar with some of these functions. So the first thing we would be calling on is the constructor, and we can just go ahead and make sure that our constructor works as intended. So we could basically say my stack equals stack, all right? And basically we would be calling the default constructor. So call the default constructor from the stack class, right, to instantiate a new stack, right? And so this just creates a new stack object. So hopefully that's clear to you. And so that would be basically what we're working with here. So stack, right? And then what we're going to do is we're going to start adding elements to it. So basically we're going to start adding dinner plates to the stack. We're going to start adding items onto it, right? So the first thing that we could do is we could add any type of element to it. So it's just you know, we could say Jimbo, right, equals person, and then we could create a person object and add the person to the stack, person of Jim and 22, right? And then you could say basically my stack.push, right, of Jimbo. Okay, so hopefully that makes sense to you, but you could add anything onto a stack, right? And we're getting a Python enhancement proposal. I'm not sure why it doesn't like that, but it says typo, so it thinks that we spelled that incorrectly. So what we're going to do is just save that. But anyway, what we're going to do is push that, and then you can push other data types too. You could push a false, for example. Just pushes the false Boolean, right? That's still a data type. You could push. How about hot dogs, right? You could go ahead and push, how about a float? How about something like 3.52, something like that? And then what we're going to do is we're going to want to go ahead and peek at the top of the stack. So we would want to go ahead and get a sense of what element is currently on top of the stack. So what we're going to do is we could say print of my stack.peek. And so again, like we said, this returns the uppermost element without removing it. Okay, so hopefully that makes sense to you. So now if we go ahead and run main.py, what do we get? It says 3.52 because that's the element on top of the stack, right? And I think we're also printing some other stuff from earlier, so we can go ahead and try to delete that code real fast. So then if we go ahead and run this code, we get 3.52 because that's the element on top of the stack, right? And then no matter how many times we print that, if we print it 3 times, then we get 3.52 3 times. But what if we were popping every time? So what if we were going to go ahead and return the uppermost element and remove it? So and remove it, right? So you would go ahead and have to change the comment here, but we would be removing it every time. And so therefore we would be removing elements from the stack, and the top of the stack would be changing, right? The top of the stack is not going to be the same element every time, because every time we do that operation, we're removing an element, right? So we had Jimbo, and then on top of Jimbo, we put false. And then on top of false, we put hot dogs. And then on top of hot dogs, we put 3.52. But then if we pop off the 3 top values, we're going to see 3.52 fall off. And then hot dogs is going to fall off. And then 3.50, and then false is going to fall off. So hopefully that makes sense to you. And then what you could do is, you know, there's other ways to do this. So now what you could do is you could say my stack dot print stack, right? And so the print stack doesn't accept any inputs, but now you could just see what elements are still in it. Now you would just have Jim is 22 years old, because now, you know, there's not really anything left in that, right? And so what if you said length of, you know, my stack dot items, right? And so what if you wanted to go ahead and look at the length of the items list that was representing your stack? And so hopefully it would just show one element, because at that point Jim is 22 years old. You know, that string representation of the person instance is the only thing left in your stack. So hopefully that shows you a couple of the methods of stacks We'll review that in the next video, which will be our very last video, and also talk about a new topic called cues. From Emails03, thanks for watching, and please subscribe.